Hello everyone, in this video I'd like to use TI Portal and S7-1200 PLC, and I will use TI Portal MC motion control function blocks to show how can we program the motion control command to control the step motor driver and the step motors. At this step motor topic, I used two videos before to show firstly how can we wire from the PLC to the step motor driver, especially to wire the 24 voltage from the PLC to the step motor drivers. We will involve the resistors. And second video, I showed how can we set up the TO technology object, set up the axis so we can use the control panel to control the step motor. After we verify this axis control, then we can use the program to control the axis. Then using the program, we can control the step motor drivers and the step motors. So basically, this is three significant steps while using the PLC to control the step motors. Alright, let's start this topic in this video. Alright, now we can use the axis by using this commissioning panel to control this step motor. Then the next thing is we can use the program. The program is going to control this axis. This axis will run as a bridge, and because we already verified this axis can control this hardware drive, then that means as long as we can use the program to join this axis, then the program can control this hardware motor. Okay, this is the two steps. Firstly, use the axis control the hardware. Then we can use the program to control the axis. Then we are able to use the program to control the hardware drive. Okay, let's go to the program. And in this case, I will use a very simple way because basically for the people using the step motor, most of cases, they are new starter. So I will not using any fancy program or any little bit high advanced program. I will use very basic way. For a little bit higher end programming, you can refer my other motion control videos. Here, firstly, let's create one DB. I will firstly define some important variables first. Here, for the data block, I will name the DB underscore step motor 1. If we name this step motor as a number 1, okay, and we can select the number, for example, 11. All the data belongs to this step motor 1. We will define the variables in this DB. And here, we can declare some variables here. We can go offline first. And while we are talking about the MC function block programming, so typically all the function block we could use, they are under the technology and the motion control here. Okay, so if I close here, power, reset, home, hot, you can read the detail by using help. Click the F1 to read the details. Typically, we will use power, reset, home, hot, jog, and move relative or move absolute. To control those MC function block, we definitely need some command. So here, I will firstly declare some variables we will use. For example, the first one is enable power, right? So here, I can declare as enable MC power. Then the next one, that could be the execute MC reset. Then I will declare all other variables we could use. Okay, I declared MC home command hot, jog forward, jog backward, velocity trigger the move relative and trigger the move absolute. And other than those bool command, we also need the set point. For example, the speed, velocity set point, and the positioning set point, and the absolute position set point, right? This target value. Okay, I declared couple real. Take care, they are real set point. For example, the speed control, we need a speed set point. And for the relative position, we need to set the relative position as well as the speed of that relative move. Same as the absolute. We need to set the absolute position as well as the velocity to run this position, right? Then we will feedback the position and the speed. The two typical ones, they are actual velocity and actual position, right? So we will grab the actual position and the velocity from this axis so we can monitor the position and the velocity. Okay, those are the typical command, set point, and feedback. Then let's go to the program. Okay, we can flow this first. And we can organize all the program into a function. So let's create a function, still named 11. And we can select the ladder logic. And this we can name as FC underscore step motor number 1. Okay. And then once we create this FC11, go to the OB1, call this function, and then double click the detailed program we can program under this FC11, inside this 11. Okay, then follow this, we can firstly program the power. We can shrink this and go to the motion control, power. Drag here, then it will automatically show this MC power. So this is the step motor 1. So let's call that M1. Okay, M1 power. Okay, then we can drag this power command to this enable. And then this axis means we will assign, so which axis this MC power will control. So using this TI portal, we can drag this axis here. This is the axis 1, is the motor we are controlling. So we can drag this to here. Then this allows this function block to control this axis. Okay, command is power on. Then we can drag the reset. Again, this is the motor 1. Okay, and same thing, the execute, we will execute this reset to here. And the axis 1 will assign to axis 1. This is the control target. And next thing is home. Home is used to home the axis. Okay, there's underscore M1. Okay, so we can drag this axis 1 here, execute. Execute, we have the home execute command here. And the position. So if every time when you home the axis as a 0, so we can leave this 0.0 as a default. If you are going to specially set a value as the initial, as the homing position, so you can set the position. Okay, or you can declare one set point set as the home position. Okay, in this case, I'm going to set a 0.0. Every time when I trigger this command, then the axis of the position value will directly set as a 0. Okay, home. After this, more important is how to stop the axis, the hot. So let's drag this hot, M1. Okay, then let's drag this MC hot execute command and assign this axis 1 here. Okay, every time when we trigger this command, the motion, the axis will stop unless the axis got a new motion command trigger. Then the jog forward and the backward. Jog function is very important. Basically, you can use your HMI to manually forward and backward running your step motor. So MC jog, motor 1. Okay, axis, assign axis 1. Forward, backward command we declared here already, this 2. So we can assign this jog forward bool to jog forward and jog backward bool to jog backward. And here, this is the velocity here, set point. For this case, if I'm going to run my motor slowly, for example, 36 degrees per second. So this is a very slow speed to jog it. So I can slow cramping step motor to forward or backward run. You can definitely use one variable to control this velocity, but typically this value can be set from the HMI. So you can adjust this velocity speed from the HMI. Then the motor will move forward direction and turn on this backward on. So the motor will run the backward direction. But when this command go off, your drive will stop. So this is the momentary button here. Okay. So this is the momentary command here. Okay, it's not a trigger command. It is a momentary command. Okay. Then let's see the velocity control and the positioning control. Those are 3 very important commands. Basically, while you are using your step motor to do the auto sequence control, typically velocity, relative, absolute are the 3 typical function block to control the drive. So let's firstly program this MC velocity here. M1. So velocity, let's assign this axis, which axis is controlling, okay? And execute, okay? MC velocity execute command. Then the velocity target. So let's go to this set point velocity, okay? So here you can also set the start value. If we download now, your start value is 0. If you forget set everything, even your trigger, the drive will not move because your set point velocity is 0, right? So typically for this velocity, we can set 360 1 revolution per second, right? As a speed initial value or default value. So I can drag to here. This is the target velocity. This is the velocity. Then let's go to this move relative. Move relative. Okay, here. Okay, M1. To trigger this move relative, so we can drag this move relative command and assign this axis. And then we can see to move to a distance, we definitely need the distance setting and the velocity. So we declare the two variables here. This is the distance target, okay? And this is the velocity, okay? How fast we will run this distance, okay? This is the move relative. Then the last one, we will program the move absolute, okay? Okay, move absolute. We'll assign this axis and the trigger command. Trigger command MC move absolute. And the position setting. So here, this is the target position setting. And this is the velocity. Okay. And typically, the velocity, we can set the initial value, a default. So we can set 360 here. Set 360 here. Okay. Then distance, we can directly set the distance. Or we can use the program to override this target position. Then we will see this is all the command. Again, let's go back to the top. So we have the power, reset, home, hot. Hot is used to stop the drive. And we have the jog, velocity move, move relative, and move absolute. Okay? And also, personally, I would recommend we can program this MC hot at the bottom of all those commands. Okay? Just cut it and paste at the bottom of all those commands. Because if you fire the absolute or any other motion control, meantime, you turn on your MC hot, then your MC hot at the bottom. So this is the last command. Your MC hot is the last command, so you are still able to stop your drive. Okay, this is the typical way. Always put the stop command or hot command at the end of all other motion control command. Okay, basically we program everything. The last thing is how can we grab the velocity and the positioning value to these two variables. So we can use the move command. So we can go to here, basic instruction, and go to the move operations. Move. Move means copy, right? Let's grab two moves here. And the first move target, this is the velocity. So put the right side. And the second line, this is the actual position. The data source came from this axis. Okay, so the axis, if we double click, all the data from this axis, we can click, right click, and go to this OpenDB editor. Then all the variables is showing here. And typically, if we go to the static, and we can see this is the actual position and the actual velocity here from this axis DB. Then if we flow this, we can drag this actual velocity to this velocity. This comes from the axis, all right? And then this actual position we can drag to here, okay? You can see this full name, axis dot actual velocity, axis dot actual position. Okay, this is a very typical all the data, all the command we control one axis, one step motor drive. Okay, now we can download. Load. Alright, after the download, we can double click this FC11 we just programmed and jump in and let's go online. And now we can manually toggle all those commands. So first things, we can enable the power. Don't forget, enable the power. Okay, if you see any fault or error status here, so you can trigger this reset to reset the fault. Okay, so now let's enable. Don't forget, turn on, always turn on. So no error, that's good. And in the real case, once we turn on this enable, again, the enable command actually will send to the step motor driver. But default, this driver is enabled, so we do not need to send anything here. But this enable also enable all other commands below. Okay, now we enable this drive, then we do not need to reset anything. And we can firstly monitor this actual velocity and actual position now. So the current position, we were parking at 360. So we see this actual position has been 360. But now if I trigger this home position, so I can trigger and we can watch this value here. Trigger, then it is set to 0. The 0 comes from this value. We can also change this value, depends on your application. Okay, don't forget, turn this off. This is the execute trigger command. Okay, so now the position set to 0. And now if I jog this command, let's turn on the forward. Forward. Now we can see it's running very slow, run 66 degrees per second, basically 10 seconds per revolution. Okay, if I turn off, it will stop. Again, backward, turn on, it will run backward. 10 seconds per revolution. Okay, turn off, I turn off. This is the momentary command, okay? And then we can run this velocity. If we run 1 revolution per second, positive direction, then every time we trigger this, we can hear the sound shows difference. 1 revolution per second. Okay? Take care of this. This is the execute. So this is the trigger command. If I turn this off, the motor will not stop. You need to be very careful about this. This move velocity only used to control a run. If we like to run another speed, for example, if we change to 180 here, you will see the motor will not change to 180 unless till you trigger this command. It will run a slower speed. Okay? Let's set another, say, 36. It will not execute now till we trigger again, rising edge. Okay, if we rising edge, we will see now the speed going down. And we can use the in velocity to verify this. Okay, however, we cannot stop it unless you set to 0 and trigger this execute. So how to stop? Well, the motor is running the velocity mode. Okay, so to stop the drive, we scroll down, we have the MC hot command, right? So meantime, we can see this position, okay, and the velocity. So if I trigger this hot, we will see the drive will stop. Speed is 0, and this is the current position. Okay? So this is the move velocity. Always take care, the velocity will be only updated to the drive every time we execute this command. It will not change on the fly. Okay, so you need to program something every time your target speed change, then you trigger a new command to this execute command. Okay, this is the move velocity. Then let's go to this move relative. Okay, so current position, this is a really huge value now. We can run the backward distance. So we can run the velocity, for example, negative 360. Okay, and we can run, let's say, 3 revolutions. 3 revolutions, 1080. Okay, now let's trigger it. Okay, we will see it has error here. The reason why I set a negative. So we can set this. So let's travel negative 1080. But the speed, we always set the positive 360. Okay, then let's trigger again. Trigger. We will see the distance negative, that will traverse to the negative, run 3 revolutions. If I trigger again, it will run the negative 3 revolutions. Ready? Trigger. It traveled 3 revolutions towards to the negative. Okay, if I set the 1 revolution, negative 360, with this speed, trigger 1 revolution. Okay, the beauty of the step motor is cost effective, do not need the encoder, but because the step motor is controlled by the pulses number is used to control the position. So it's still running basically accurate, unless your mechanical has slippery inside. Okay, now this is the current position. Okay, this is relative. This is our current position. Now if we scroll down, go to the move absolute. For the move absolute, whatever where we are now, if our target we set to 10,000, for example. This is our absolute target with this speed. If we run a much faster 720, okay, 2 times faster. Now if I trigger, we will see the actual speed, actual velocity, and this position. So now let's trigger. 1, 2, 3, trigger. And let's watch this value, actual position. Okay, it stopped to this actual position 10,000 with a faster speed. Okay, now if we travel to 5,000, okay, let's trigger again. Trigger. Run to 5,000 absolute position. Okay, now if I set a lower speed, so if I leave this true on, it doesn't matter because it only care about the rising edge. Okay, if I set a 360, for example, so we will see it won't be triggered. Okay, I will set a new target. Let's say this time we will run to the negative 100, the negative 360 degree. Okay, then let's trigger. Turn off, turn on again, it will start run. Ready? Go. Okay, it parked as negative 360 degree. Okay, this is speed, this is the target. Okay, so this is the move absolute, and basically while you are programming for your application, so the actual velocity and actual position are very useful. Typically, this is the 2 common value you will use for your application, for your auto control or any other control correlated with this step motor position or speed. Okay, and once you stop your machine, after you halt your machine, don't forget you turn off your power. Then your system is safe. If your power off, turn off this enable. if you try to jog your drive will not move. See, this will turn arrow. Okay. Okay, you see, jog doesn't move anymore. So velocity, if we trigger, it won't move. Always show arrow. Okay. Therefore, this power enable is very important. Make sure if your system, the safety gate is not on, or if your machine's condition is not fully ready yet, so you turn off your enable. Okay? After everything condition is good enough, then you enable your drive. Then you can jog your drive, velocity control or positioning control. Alright, this is step motor control. So typically if we review, we create this axis and then we use the configuration, config this. Basically this axis in the PLC side will run as a driver. This driver joined the program and the hardware together. So at the right side, this is the hardware. We assign the hardware channel and also assign some mechanical data, maximum speed, the start-stop velocity, and this scaling, this load movement configuration. And then we will use the program. So from this OB1, we call this FC11, and inside this FC11, those are the typical MC motion control function block: power, reset, home, jog, move velocity, move relative, and move absolute. And all those commands locate at the very right side, go to the technology, and under those motion control here, those commands. Alright, this is the video for today. How to use the Siemens 1200 PLC to control the step motor drive. Thank you for watching. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.